everyone, welcome back to today's tutorial. We are diving into the fascinating world of linear regression, a fundamental techniques in the machine learning that allow us to model relationships between four variables. Okay, so join me as we explore the theory behind the linear regression and the implementation each in the Python. Okay, so let's get started. So first of all, I am introduction to the linear regression in machine learning. Okay, so the machine learning, it forms the backbone of the predictive modeling, allowing us to make the prediction based on the relationships between variable. Okay, so either it's predicting house price or stock values or anything is between. So linear regression is our go-to tool. Okay, so the linear regression is two types. For is the simple and multiple. The simple line regression is modeling the relationship between two variables, and multiple linear regression is the extending the concept the multiple predictor variables. Okay, so now I am understanding the linear regression. So the linear regression is about finding the equation of a line that best fits our data. So the equation is the from for equal the y equal for mx plus b, where m is the slope and b is the y-intercept. Okay, so now I am implementing the linear regression in Python. Okay, so let's start it. So let's implement the linear regression in Python. So using the sklearn library, so one of the most powerful and user-friendly machine learning libraries out there. Okay, so first of all, I am implementing the linear regression in Python. So first create is from, okay, and then create for is the sklearn dot model. Okay, it's model the selection. Then again create for is import for train and test split. Okay, so next create for from is create is the sklearn for dot is the linear is model for the linear model. Okay, then create for is import is the linear regression. Okay, so next again create for the import file is from, then again for sklearn dot create for the matrix. Okay, so it's matrix, then create for is import. Okay, and create the mean. Okay, so mean squared for error underscore error, and again create for the import file is import, then create for the matplotlib library. Okay, dot pyplot as plt. Okay, so last one I am import file create is the numpy. Okay, it's numpy as np. Okay, so now complete the import filing in this linear regression. Okay, so now I am generate some random data for demonstration. Okay, so let's create for np dot is create the random, then again then create for the sheet. Okay, so now I am create for the value is 42. Next time create for is the x equal to into its np dot for the random and dot is the rand. Okay, it's a numpy method for, then the value is 100 for 1. Okay, so now I'm again create for the next step is y equal to 4 is addition, then create for is 3 is multiplication, then create for x and is the addition again for create is the np dot it's random, then dot is the rand dn. Okay, so then the create is the value for is 100 for 1. Okay, so it's complete. And now I'm create for is the split the data into the training and testing set. Okay, so let's create. So first time create is the x for underscore is train. Okay, it's train, and then create for is the x for underscore test. Okay, and again create for is the y train. Okay, so y underscore train for the y underscore for test. Okay, it's test. So this is change for test. Okay, so it's complete. And now it's equal for is the train test split. Then create for is the value is for x and y, and create for the test is the test size. So test size is equal for 0.2. Okay, so and then create for is the again create for the random. Okay, the random underscore state is 42 because it's the complete. Now I'm create for is a linear regression model. Okay, so create for is model. Its model for equal the linear regression. It's the linear regression model. Okay, so next time create for is the fit the model through the training data. Okay, so create is model dot is the create for its fit, then create for the parenthesis is x underscore for train, and then create for the y underscore is train. Okay, so it's the fit for training data. Next time create for the make predictions on the test data. So create for y underscore is create for the predict PRED. So it's equal for that model dot is for predict is the value for its call is extreme data. Okay, so next time create for the visualize the regression line. Okay, so now I'm create for is the plt dot is the scatter. Okay, it's scatter, then create for parenthesis for x and y. So now I am create for is the alpha. Okay, it's alpha equal 0.7. Next create for is the level. Okay, it's create for the level equal, it's level equal single quotation create for is the original data. Okay, it's original data. It's complete this line, and next line I'm create for is the plt dot for its plot, then create for parentheses is create extreme, it's the x test, and create for the y prediction, and next create for the color, its color equal the color is single quotation create for is the red. Okay, and create for the its line weight. Okay, line, its line weight equal the single quotation for the create is the linear regression. Okay, it's linear, it's regression. Okay, so next create for it's the complete for the linear regression line, and I am again create the its create for is PLT the scatter for y equal, okay, in the space. So this space for the alpha is 0.7 and the label the original data. So this line is complete. It's not error. So now I am create for is the PLT dot title. Okay, its title. The title is the linear regression in Python. Okay, so the parenthesis for single quotation create linear regression in Python. Okay, so next line I'm create the x label for plt dot x label, then parenthesis single quotation create for x. Okay, so next line create for plt dot y label for y. Okay, it's y, and last line is create for is the plt dot I'm also create is the legend method. Okay, and then create for the show method. Okay, plt dot create is show method. Okay, so in this line are completed, but I am also created the calculate the mean squared error. Okay, so let's create. So first time create is the MSE. Okay, so it's the short form the mean squared error function. Okay, so create is equal, then create for the mean squared is the error is the scalar matrix regression. So the regression for create is the y for underscore test, and again create for the y underscore is the prediction. Okay, so now I am create for is the print function. Okay, so the print for f and create the single quotation create for mean squared error. Okay, is mean squared error. Okay, so the error is create for the index is MSE. Okay, so this code are completed. Okay, so now save this code and let me run this code. Okay, so just wait. Okay, so the result is printed. So here we generate for some random data for the split into its training and testing set. So create a linear regression model is fit to the training data, make prediction and visualizing the regression line. Okay, so the mean squared is the error is a matrix to evaluate how well our model is performing. Okay, so this is the result for in this tutorial. Okay, so here you are the congratulations are the mastered linear regression in Python. So a skill that opens the door to predicting future outcome based on historical data. So keep exploring, keep predicting, and keep your coding. So thank you for watching and happy coding.